Alright guys, welcome into the lesson. Today we're going to go over the first couple pages of basic stoichiometry. One thing that I do want to outline, you guys should be tuned into this page. What I want you guys to focus on are these coefficients or these numbers right here. So this is going to represent the number of moles. So, in this particular case, I have 2 moles of A plus 3 moles of B will give you 5 moles of C plus 4 moles of D, right? So let's just keep that in mind, right? So this is our equation, and for some reason, it's kind of balanced that way, okay? So let's look at question number 1. What do the coefficients of a balanced equation represent? They represent, like I said, the number of moles, right? Question number 2, if 6 moles of A are reacted, how many moles of D are formed, right? Now, when we look at this, we're always going to reference our balanced equation, right? So we want to make sure first and foremost that our equation is balanced, and that doesn't quite make sense here because you have 4 different letters, but it will make sense when we actually start getting into the chemistry of it, okay? Perfect. So what I'm going to do is you always start with what you have, so 6 moles of A over 1. And since I have moles of A up here, I have moles of A down here. And I'm trying to get to moles of D, correct? So I'm going to put moles of D right here. Now, this is where it gets tricky because now you have to reference your balanced equation up here to for the ratio, right? So I have how many moles of D in my equation? I have 4 moles of D. And then how many moles of A do I have? I have 2 moles of A, right? Now, when you do this, you multiply the numerators and then divide by the multiplication of the denominators, right? So 6 times 4 is 24, divided by 2 is going to be 12 moles of D. This is basically saying that if I have 6 moles of A, according to this equation up here, I'm going to get 12 moles of D, right? Let's move on to the next problem set. If I have 15 moles of B, how many moles of C are formed, right? So let's do a quick example once more. So we have 15 moles of B. Remember, you always start with what you have. That's going to get annoying. I know, I'm sorry. If you have moles of B up there, you need moles of B down here because you want to cancel these off and you want to get to moles of C, right? Now, let's look back at our ratios up here, and I have how many moles of C for my balanced equation? Well, I have 5, right? And then how many moles of B do I have? Well, I have 3, right? So 3. When I multiply this out, I'm going to get, what is that, 45 divided by 3 is going to be, holy cow, 15? Is that even correct? No. Holy cow. I'm sorry, guys. I'm looking at the screen, looking at the paper at the same time, and kind of trying to go from there. Whoopsies. So that would be 75, right? Yeah, 75 divided by 3 is going to be 25. There we go. 25 moles of C. Perfect. Let's do this problem down below, number 4. So let's go ahead and do that one. 8 moles of A. I'm going to go faster now because hopefully you guys are in the routine. Bam. Moles of A down below. And then you're trying to get to moles of B. So moles of B. My ratio is I have 2 moles of A. 3 moles of B, you go do that. 8 times 3 is 32 divided by 2. It's going to be 16. There we go. Moles of B. Perfect. Now, one thing that I did forget to mention is that this whole document with the key is already on Drive. So if you click on a document that looks like this on Drive, if you scroll all the way down, it'll actually have a key that I typed in there myself with all the steps. But of course, it won't have the dialogue provided. It'll just have the work, okay? All right, let's flip to the next example here. What I'm going to do is we're going to go over this next one as well. So notice you guys have a different equation up here, right? It's balanced. So question number 5. If 21 moles of A reacted, how many moles of C would be produced? Well, you always start with what you have, 21 moles of A over 1. And if you have moles of A up there, you're going to need moles of A down here. Oh, sorry. You're trying to get to moles of C. So what is your ratio? Well, for this one, you have 2 moles of A. and then 5 moles of C, right? So when you go ahead and multiply these across, I think you get 105 divided by 2 I believe so, right? Yep. 105 divided by 2. And that's going to equal 52.5, I believe. 52.5 moles of C. Now, I'm going to skip this problem. I'm going to skip this problem because you would solve them the exact same way. And so hopefully you guys can do those on your own. I'm going to go ahead and shut this video off right now. And then the next video will actually be going over the sample problems on your worksheet. So let's keep going. It'll be over the next page that kind of looks like this. And you know what, actually, let's just go ahead and do it on this video because I still have time on this video. Okay, now let's look at this equation here, right? So you're going to utilize this equation to answer the rest of the following problem, or the following problems. Now, I want you guys to notice one thing. There are blanks in here for a reason, right? So let's go ahead and look through this. How many, first of all, foremost, N2 plus H2 gives you NH3, or also known as ammonia. Okay, this is a synthesis equation, or synthesis reaction, because you have two individual components coming together to make one. Now, let's see if it's balanced. How many N's do you have on the left side? Well, you have 2, right? N2. How many H's do you have on the left side? Well, you have 2. And then how many N's do you have on the right side? You only have 1. That's a problem, right? So we have 2 on this side, we have 1 on this side. So I'm going to go ahead and put a number 2 here, right? And if I do that, I have 2 times N1. So now I have 2 N's. My N's are balanced, right? But now when I do that, I also have to distribute this 2 over here. And that's going to give me 6 H's, right? And now if I go over to the left, I have 2 H's, right? And so that is not balanced. And so what I'm going to do is I'm going to put a 3 here. So 3 times 2 is going to give me 6. And now it's balanced, right? And this is just a good old Ninja 1. So this is going to be the equation that you're going to reference. Kind of like the equations that we did on the other one, right? All right, here we go. If 0.052 moles of N2 are reacted, N2, how many moles of NH3 are formed? So let's go ahead and do this together. You always start with what you have, 0.52 moles of N2, and I am going to ask that you guys write this out completely. Bam. So if I have moles of N2 on the top, I need moles of N2 on the bottom. I'm trying to get to moles of NH3. Right? And so what is my ratio? Well, I have to look back at this puppy right here, right? So moles of N2, I have 1 of them, so I'm just going to write a 1. And then moles of NH3, well, I have 2 of them, right? So that's the ratio. This is telling me that for every 1 mole of N2, I'm going to have 2 moles of NH3 produced, right? And so now I just multiply across, and then I'm going to get something like this. I believe if I can do this in my head, 0.104 moles of NH3. Okay, let's keep going. Let's do number 10. All right, let's do it once more. 0.052 moles of N2. How many moles of H2 are going to be used up? Well, if you have moles of N2 up here, you're going to need moles of N2 down here. You're trying to get to H2, right? Moles. So what is the ratio? Well, you have, once again, 1 mole right here of N2. And then you also have, what is the coefficient over here? Well, you're going to have 3 moles there, right? So then your answer is going to be, if I could do this in my head, let's see, 0.156, I believe. 0.156 moles of H2. All right, question number 11. Okay, this is where it's going to get pretty sweet. Actually, you know what? No, I'm going to skip number 11 because it's the exact same setup. I'm going to skip this one because it's the exact same setup, right? And now we're going to flip to the next couple pages. Actually, I think I'm done with that particular problem. Wow. Okay, we're going to end this video now, and then what I'm going to do is I'm going to go over the practice problems on the next video that you'll see, and the practice problems will look like this right here. So it'll say worksheet on stoichiometry, show all work required. Okay, perfect. So tune in.